In Activity 9, Investigating Rock Models, students dissect the rock models and perform tests to identify their mineral content. Students then dissolve the model rock remains in water to observe settling patterns of different elements, and finally evaporate off the solution to observe which crystal shapes form. You will need the following materials from the kit: Activity Sheet 9, Activity Sheets 3 through 6, Mineral Data Sheets, Steel Nails, Vials with Caps, Glass Plates, Magnifiers, Streak Plates, Evaporating Trays, Plastic Trays containing 4 rock models from Activity 2, Vinegar, Rock and Minerals Video, and the Rock Guide. You will also need to provide safety goggles, newspapers, pennies, DVD and monitor, and tap water. To prepare for the activity, make a copy of Activity Sheet 9 for each student. Students will also need their copies of Activity Sheets 3 through 6 and their mineral data sheets. Make sure to have the Rock Guide on hand for reference. For this activity, each student will need a pair of safety goggles, 1 nail, 1 vial with a cap, and the rock models they made in Activity 2. Each group of 4 students will need 2 pennies, 2 glass plates, 2 streak plates, a bottle of vinegar, 2 magnifiers, an evaporating tray, some tap water, and enough newspaper to cover their work area. Make sure that students wear their safety goggles during this activity and wash their hands after handling the specimens. To begin Session 1, encourage students to recall the rock models they made in Activity 2. Introduce the term conglomerates to the class, or a rock that is made of mineral and rock fragments held together in clay or another cementing medium. Students should realize that the rock they made in Activity 2 could be considered a conglomerate. Distribute Activity Sheet 9 to students and tell them to write these ingredients in the space provided: alum, clay, gravel, salt, sand, talc, water, and 3 mystery minerals. Ask students, how is the process by which you formed your rock different from how rocks form in nature? Students should remember that the conglomeration of materials in their investigation took less than a week to form. Help students understand that even though the same cementing materials can be found in nature, rocks formed naturally are fused together by extreme pressure and/or heat and take thousands of years to form. Next, demonstrate for the class how to break apart the rock with a nail. Place the rock flat on a work surface and firmly and evenly apply pressure with the nail until the rock breaks apart into large chunks. Repeat the process until the rock has been broken into small pieces. Note that under no circumstances should students attempt to break the rock into pieces while holding it in their hands. Then, instruct a member from each team to retrieve a plastic tray containing his or her team's 4 rock models. Then distribute all of the other materials except for the evaporating tray. Students should cover the work area with several layers of newspaper to protect against scratches. Next, tell students to break apart their rocks with a nail and set the larger pieces of rock, the chunks of gravel, sand, and minerals, to one side in the plastic tray. Encourage students to identify the fossil item included in their rock model by having them look for the imprint the fossil item may have left. Next, have the students prepare a setup for Session 2. Put some of the powder, residue, and small pieces from the rock dissection into a vial. Then, students should fill the vial 3/4 full with water, cap it, and shake it vigorously. This shaking will dissolve some of the particles and allow other different size particles to settle at different rates, forming layers of sediment. Encourage students to review the ingredients in their rock model. Ask students, which particles do you predict will settle to the bottom first? Gravel, sand, clay, or talc? Students will probably suggest that the larger, heavier particles of gravel and sand will settle to the bottom first, before the particles of clay and talc. Instruct students to record their predictions on their activity sheets and set aside the vials overnight for further study in Session 2. Return students' attention to the larger pieces of rock on their plastic trays and remind them of the luster, hardness, streak, and acid tests used to test minerals. Then, have teams conduct these tests to identify the 3 mystery mineral pieces in their rock models. Encourage students to use the mineral data sheet and prior test results recorded on Activity Sheets 3 through 6. The students' test results will reveal the following: The hardness test identifies quartz, the acid test identifies calcite, and the streak test identifies pyrite. To conclude Session 1, return the nails, plastic trays, streak plates, glass plates, and bottles of vinegar to the kit. Note that the pieces of quartz, calcite, and pyrite may be saved or discarded, and students can take home the remains of their rock models. To prepare for Session 2, have students retrieve their vials. Plan to conduct Session 2 a day or two later. To begin Session 2, have students retrieve their vials. Warn them to be careful transporting the vials to their work area so as not to disturb the sediments. Ask students which particles settle to the bottom first, pieces of gravel, sand, clay, or talc. Students should observe that the larger pieces of gravel and sand settle to the bottom first, before the smaller pieces of clay and talc. Then ask, have you ever noticed layers of sand and shells at a lakeshore or at the beach? Help students understand that the size and weight, or density, of particles determines which ones will settle first. Inform students that layers of sediment, which eventually form sedimentary rock, are deposited in this way. After students have recorded their observations of the sediments in the vials, remind them of their experiences with crystals and crystallization. Ask students, why do you think you were asked to shake the vials of sediment and water? Students may suggest that they shook the vials so that some particles would dissolve in water and can then be recrystallized and identified. Ask students to predict what will happen if they allow the liquid in the sedimentation vial to evaporate. Students should infer that if they allowed the liquid to evaporate, crystals may form. To conclude Session 2, demonstrate for the class how to pour liquid from a vial into an evaporation tray without transferring any solid material. Then, distribute the evaporation trays and instruct teams to pour the liquid carefully into each of the 4 wells in the trays. Students should place the trays in a warm, well-ventilated area. To conclude Session 2, do not allow students to pour the sediments down the sink drain, as solid particles should always be discarded in the waste can. Vials and caps should be rinsed, air-dried, and returned to the kit. To prepare for Session 3, have students retrieve their evaporation trays. Plan to conduct Session 3 3 to 7 days after completing Session 2, or after noticeable crystals have formed. To begin Session 3, encourage students to observe the crystals carefully with the magnifiers. Ask students, what is the shape of some of the crystals? Most students will be able to identify cubic-shaped crystals in their trays. Remind students of the rock ingredients, which are recorded at the top of Activity Sheet 9. Then ask, based on the ingredients you used in your rocks and what you know about the shape of salt crystals, can you identify the cubic-shaped crystals you see in your evaporation trays? Students should identify the cubic-shaped crystals as salt crystals. Tell students to write and draw their observations of the crystals in their trays on their activity sheets. Finally, show Part 2 of the Rocks and Minerals video, Secrets in Stone, to the class after they have completed their activity sheets.
If you love digging deep to solve mysteries, you'll love this. Rocks, minerals, and fossils can be clues, and the mysteries they help solve are some of the biggest mysteries on Earth and beyond.
To conclude Session 3, the evaporation trays should be rinsed, air-dried, and returned to the kit, along with the Rocks and Minerals video. For science background, reinforcement activities, curriculum connections, and information about the Delta Science Reader, please consult your DSM Teacher's Guide.